Good evening, madam.
Dear participants, today we have the second session by Dr. L. Sivaramakrishna sir, who is a professor of mechanical engineering, University College of Engineering, Osmania University. He currently serves as director of the Center of Product Design, Development, and Additive Manufacturing, R&D cell and examination cell, and is also SPOC for Swayam NPTEL. With 30 years of teaching and research experience, he has guided 7 PhD scholars, over 100 ME projects, published 100 papers, authored a textbook on production technology, and completed 50 lakhs worth of projects funded by UGC, AICTE, and DMRL. His research areas include 3D printing, Industry 4.0, CAD/CAM, SIM, and cloud manufacturing. He has delivered 150 plus invited lectures, organized 30 plus STTPs, conferences, 3 AICTE ATAL FDPs, and a GIAN program with Georgia Tech. He also collaborates with major hospitals on 3D printing applications in cranuloplasty and serves on DMRL's projects monitoring committee. Awards include the Best Engineering Teacher in the year 2023 and Best Research Paper in the conference called ICREIT Bhubaneswar, and he has been visited the countries like USA, and we have he's also having active membership of IEI, ISSE, ISSS, and IAENG. I welcome you, sir, to the today's session. Now you can take the session, sir. Thank you.
Thank you, madam, for introducing. First, I would like to thank the management of GMRIT and especially Naidu Garu, Dr. Naidu, head of department, and others, principal, for giving me the opportunity to share my knowledge, what are the knowledge I gained on future challenges in AM, and what I am going to challenges and future trends in AM. So definitely, I congratulate you for selecting such a wonderful topic of your FDP, which is most related to the present scenario of Industry 4.0, role of AM in the era of Industry 4.0. And I would also like to express my regrets for joining late because of some official works it got delayed. And I am going to present now a topic on challenges and future trends in AM. Let me share the screen. Hope my screen is visible to all. Am I audible? Hello?
Yes, sir.
Yeah.
Yes, sir. Yes, sir. Audible.
Yeah, because this is online, no, we don't know. I'll be going on telling, and sometimes I may not be observing that you are able to see or you are able to hear my voice. If anyone finds that, you can stop me and you can inform me. Also, a little bit I'll be asking some question. Please try to interactive, even though it is late evening, but still I hope you will be all enthusiastic to learn about this challenges and future trends in AM for Industry 4.0. So let me start our journey with my first screen. I hope what you are seeing on the screen are the left side top corner you see. I am going to show it with the marker. So this is for planning a surgery called orbital volume surgery, zygomatic fractures. We use additive manufacturing for planning that surgery. We make this and doctor plans according to this and performs the operation, and which reduces time of operation and improves the efficiency. Another application that you find on the right side top corner is you can nowadays see in most of the cars you see the OVRMs, overview rear mirror, you see an LED light. So earlier it is unimaginable to put a small electronic gadgets in this one, but now this is the de facto scenario in all the cars default, whether it is the lowest model or the highest model. This became a common thing. So you can know the application of additive manufacturing a lot in all the automobile sector are now adopting this technology a lot. Similarly, you can see this middle side, left side, you can see, you might all, or most of us Indians watch like three things. We like food, variety of food, we like cricket, and we also like movies. So in entertainment industry, where you might have seen a movie called Iron Man, or you might have seen a movie called Lord of Rings, or you might have seen a movie called Batman versus Superman, or recently in Indian versions, Indian movies also, like you might have seen Vikram, or you might have seen the other late popular movies that are available, you might have seen. There we are using additive manufacturing a lot. So this is and just why I'm telling all these things. What will be the future sectors where AM can be used? Because most of us think additive manufacturing means only related to some manufacturing products. But now these technologies don't have any boundaries, especially the technologies of Industry 4.0 don't have any boundaries. So the right side, you see this helmet, which is a safety helmet for a cricketer or for a baseball or any other sports activity. So the safety equipment for sports, you can develop this type of thing using additive manufacturing. You can also develop the shoes for the athletic who runs, or for the cricketer who uses this as a bowler or a batsman. You can see a sport shoes having the spikes at the bottom. There are specialized tools meant for specific applications. So you can use additive manufacturing in sports industry also. Not only this industry, you can also see this particular one. This is for drip irrigation. You use this type of nozzles. Now, one of my students who works in the as irrigation engineer in Telangana state government, he was doing part-time MTech under me. Then I told him, why can't you use 3D printing in your area of work? So he said in drip irrigation, they use this type of nozzles. Now we printed octagonal nozzles and performed, compared the how much the area it can wet and all those things. So we made the SLS and FDM technology for doing this one. So I can use this for agriculture applications. So additive manufacturing can be used in agriculture applications. Similarly, you can see the bottom one, recently it was done in Chennai, IIT Chennai, L&T has made a construction house in 106 hours. So this is, you are using additive manufacturing for making for civil construction purpose also. Similarly, additive manufacturing is already used in popular companies. They started using in food industry, food processing. Like you can make your own pizzas, you can make your own pastries. In fact, NASA is using this technology to send food printers to Mars, where in the future they are going to send human beings to Mars. And the astronauts who goes to the Mars, they have to stay for 2 years. The travel time is 1 year, 1 year to go and 1 year coming back. So 2 and for 2 years, total 4 years. So how they will survive without food? So for them, they have started to develop food printers where you can print the required things during their travel and during their stay in the Mars. So food printing industry is also going to have the application of 3D printers. Similarly, you can also see this very fascinating jewelry. So it's unimaginable to make in a conventional method, but using additive manufacturing, you can make such a wonderful jewelry, which is very exotic and very different design you cannot imagine. So additive manufacturing you can use in jewelry applications. So you can also use for making this horn antenna. I hope you are able to see my pointer. Are able to see the pointer? Hello? Hello?
Yes, sir. Yes, sir. Yes, sir.
Yeah, please. So this is a horn antenna used for many electronic application, communication purpose. So this horn antenna we have printed in our lab in IIT using FDM technology. Then we have coated a metallic painting on it. Then we started using it for the communication purpose. Earlier they used to make this with the tin sheets, belting, sheet metal forming, etc. But with additive manufacturing, you are able to do it more accurate and less signal loss. So additive manufacturing has got a lot of application, electronic field. Similarly, you might have seen nowadays in home decoration plays very important role. So because not simply having a constructing home, having bare walls or putting some type of wall paintings or some kind of paper, etc. Now people want to not have a 2D effect, they want to have a 3D effect. Now you can see this horse. If you see this, it appears that horse is coming out of the wall. This is very interesting, which creates interest. When you come to your home, you want to have something different. So interior decoration is something industry which is developing fast. In this also, additive manufacturing has got lot of application. So overall, you can see on my one screen I have shown some around 7 to 8 applications, but there are many which I cannot put everything on the screen, but many applications. So as application increases, the challenges will increase, and the future where you are going to use it also will increase. So before I start, we have excellent center in our one Center for Product Design Development Additive Manufacturing. We have developed into 6 crores. We have RUSARD funding. We have very capability matrix. We have different technology, SLM, SLS, SLA, Ultimaker, Arctic, etc. So present this I have not changed. Present the director is myself, Professor L. Sivaramakrishnan, and the joint director is Dr. E. Masudan Raju. The former director is Professor Sriram Venkatesh. Anyone interested to do their BE, ME, MTech internships, etc. We also do consultancy work with different agencies like DMRL, DRDL, and other companies. And also we work with hospitals in planning, developing prototypes for planning surgeries and implants, etc. So let me start with this definition of manufacturing. If I ask anyone what is manufacturing, can you, one of you unmute your mic and define manufacturing? Any of the audience? You can unmute your anyone. Yes, you can tell definition, very basic definition I'm asking. Are you there? You feel free, like,
Yes, sir.
anyone can define manufacturing.
Sir, may I?
Yeah, please introduce. Who are you? Please introduce and just tell.
Sir, my name is Saurabh Sadananda Kulkarni. I am from SSPM's Engineering College, Kankavali, Maharashtra.
Oh, great. Please define manufacturing.
Sir, I think it is a set of processes to convert raw material into finished product.
Okay. Any other one person? So set of tools for converting raw material to finished product. Okay, good. Basic definition. Anyone want to add to this? Anything new? What? You can mute, sir. Others, you can add any new word to it.
May I, sir?
Yeah, please.
Yeah. Sir, it is a conversion of raw material into the fine finished product by using a suitable machining process.
Machining, some advanced machining process.
Yes, sir.
Okay. But here everyone is forgetting one thing. Now, for example, you make a car using different tools, different technology, advanced technology, you make everything. But you might have seen some cars which are made with some, not only cars, any product which is made, or any product means it can be any film also. Film is also, I can say, a movie also a product, because movie is nowadays made with so many technologies, so many, you can know, everyone knows movies now, most of the time there are graphics, there are a lot of technologies than the actual acting. So movie became industry, film became industry. So like this, any product which you make it, but don't have any customer, what you call, demand, you call it as manufacturing nowadays in today's world. What definition you told earlier is correct when it was before 90s, when the market is not a global market. When the market became global market, then the definition changed. Because you might have seen before 90s in India, we used to have certain brands of vehicles which have got a lot of demand. But nowadays in this world, you are seeing those vehicles are not seen at all on the road, or those products are not seen on the your daily use. But you are finding new products, new models coming up. And why those products lost the race? Because they did not meet the customer requirements. So the thing that you should add for manufacturing is process of converting raw material components or parts into finished goods that meet customers' expectations or specifications. Simply making a product on your own idea, on your own industry area, but don't bothering about customer requirements, then your product will be a failure. It will not be a success. So The reason for that is the marketing, everything changed. The global, you say earlier your business is local, but nowadays you see your business is global. Your customer may not be in India, your customer may not be in Andhra Pradesh, he may not be in Telangana, he may not be in any of the states, and he may be in some other part of the globe where your product is having a lot of demand. So that means customer requirements, once any manufacturer understand exactly, then you will be a success. So that's the definition of manufacturing. Let us see, manufacturing makes, it creates wealth, sustains jobs, and it is central for any economic success. So if you see the changes that happened in manufacturing from 1908, you got the first T model car developed by the great man Henry Ford, Model T car, which has got a demand, which is whose specifications are 20 horsepower, top speed is 20 kilometers per hour, and it has got a demand, it has got a life from 1908 to 1927. Life means it has got demand in the market, because at that time there is no competition. But now if you see the famous automobile that come, for example, you take Toyota Camry hybrid car, which was released in 2013, the hybrid engine, advanced, very advanced engine, horsepower is 200 horsepower, it can reach a maximum speed of 250 kilometers per hour in 90 seconds. Very advanced features, very great car. But the demand for the car will not be more than 1 year or 2 years, because automatically another car will come, a competitor will come. That means your manufacturing scenario changed from you use the same machine for 20 years, use the same technology, same material, same thing. Everything is same for 20 years, because there is no competitor for you. Your T model car has got demand. But nowadays you cannot stay like this. I released a model car today, and after 6 months immediately I should start released another new model, another type of car, another technology, another material, another specification, everything. So that means you should understand how agile your manufacturing should be, how fast it should adapt to the market changes. So if you see the Henry Model T car, how it is made, are you able to hear the audio of this video?
Hi, this is Kelly from Car Data Video. Today we're going to have a history lesson. Of all the automobiles that have ever been designed and built in the world, there's one that stands out as most significant above them all, and that's the Model T Ford.
You can see
the Model T introduced mass production and single-handedly brought us from a horse and buggy level of technology to one where we had machines that were run by gasoline engines. Using a moving assembly line, Henry Ford was able to build these things in about 1/10 the time it took to build other vehicles by hand previous to the Model T. The Model Ts were simple, they were rugged, they were cheap, and as Henry Ford used to say, you can have any color you want as long as it's black. When they were first introduced in 1909, they sold for $950, which doesn't sound like much to us today. Back then, that was quite a lot of money. Henry Ford cleverly paid his employees $5 a day, which back then was a huge amount of money compared to other jobs that they could get. He also reduced their workday from 9 to 8 hours, but again, by doing that, he could have 3 production shifts working and hence build cars around the clock. All of this was going on at a time of economic difficulty and transition, and so the result of this is people would come from all over the country to get jobs working in Detroit at the auto factories, and of course their job of choice was with Ford.
Let me show this video. So I shown manufacturing of T model car, manufacturing of Camry hybrid car. What the difference you find between this and earlier one? Anyone can answer this? Anyone?
May I, sir?
Yeah, please.
Sir, as per my perspective, the manpower at shop floor reduces currently as compared with.
Hello? Manpower reduces 1 point next. Hello? You lost the connection. Any other person? Any other person, please? Okay. First point, as you said, the human man workers on the shop floor reduced. But at the low level, the number of people got reduced. But the higher level, there is a lot of demand. That means the demand for a person who construct the robots, the demand for a person who can integrate the different material handling device like a robot, like a CNC machine, like a conveyor belt, like a storage retrieval system, all these things. And people who know the programming, how to control the robot, how to write the code for running it, how can develop the artificial intelligence for this type of scenario, where but the demand for high-end workers increased. The demand for low-level jobs got reduced. This is what is going to happen in future also. Don't think technology will reduce jobs. Definitely technology will reduce jobs at the low level, but technology will increase jobs at the high-end level where you are paid more and you get more, what you call a quality of life than compared with the low level. Because the low-level things are done by the machines itself. The robot is going to pick everything, assemble everything, but there should be a person who can write a program, who can control the robot, you can maintain the robot, you can integrate the robot with other devices. That means your architecture design person requires more in such type of environment. So your job requirements increases and the challenge for you also changes. Now, not simply you learn one technology and live throughout your life. It is not like that. Just you learn one technology, after within 2 to 3 years, the technology gets outdated. So you have to learn new things. So always, as a person, you should try to upgrade yourself with the new technology. Then only you are going to have lot of long life and lot of survival here. That's one thing that you should learn here. The quality of work increased, the agility increased when compared with earlier. I am now able to produce so many cars in 6 months. You can see the market in the automobile sector, how many cars are getting released. Earlier, we used to have only one model car, I don't want name. That car was on Indian roads for 30, 40 years. But now you don't find that car at all manufactured and not sold in the market at all. But now you see there are nearly 70 to 80 players on the Indian automobile sector. They are coming out with new model cars every 6 months. So you see the technology evolved like anything. If you see India, this is what you used to have earlier before 90s. So this is what these models of the car or the automobile scooters we used to have. But now after 91, this changed. The reason for that is the global shifting from local market to global. Many of the global multinational companies entered into India and they started competing. So the companies which are able to compete with them stayed in the market, but the companies which could not compete, they lost. So that's the reason why I said earlier there is no option for the Indian customer. They used to have only one model, so they are forced to buy only those things. But now Indian customer has got lot of changes, lot of options for him. So definitely you switch over to the product which he likes more. So the reason for that is the demand for new product is more. The customer requires always new things, and the customer always don't want to continue with the same product for so many years. You want to change. So that's why until the company changes, evolves itself, then only it can survive in the market. So what can be the factor of the future? So automation experts are fond of saying that eventually factories will be stopped only by a man and his dog. This is a statement given by Professor D.W. Russell from Penn State Great Valley when he was attending an international conference in the UK in Teesside on it is called FAME, Flexible Intelligent Automation Manufacturing. So in that he was putting the first slide. Automation experts are fond of saying that eventually factories will be stopped only by a man and his dog. Then the only duty of the man will be to feed the dog. So can anyone answer what is the duty of the dog then? This is a slide to just tell you behind the meaning of that. Anyone can answer? What is the duty of the dog? Hello? Any expectations? You can answer any. Hello?
To obey the command given to him.
To obey the command given to the dog. And that of the dog will be to ensure that the man does not touch the machine. What is the inner meaning of this slide? Once the man starts moving to the machine, it will start barking. What is the meaning of this slide? Means future of the factory will be full automation. Automation to the maximum level. So you have very less human involvement on the shop floor. You have more human involvement in the developing integrated architecture for the all systems, in running them, in a control room, in monitoring everything, whether they are going to as per the plan or not. So that means automation to the maximum level. So this is what they said. This slide I got in 2009. So at that time they were telling the future will be most of the factories are automated. In Indian scenario also it is semi-automated because we have a lot of population and the labor cost is less. So that's why still we don't go for full automation because it involves a lot of cost. But in some Western countries, in countries where the population is very less, they already switch over to maximum automation, where the human involvement in production of the products gets less, and they'll be there in the controlling those things and developing and maintaining those items. So this is what happened industrial evolution. In the industry 1.0, 18th century, you got James Watt steam engine. Then it revolutionized the transportation and changed a lot of things. And industry 2.0 is the mass production lines developed by Henry Ford, father of modern manufacturing process. He developed the assembly of a car using that I shown the video, the conveyor belt and everything. So mass production, he pioneered the mass production process, and he developed this the beginning of the 20th century. And then comes the industry 3.0 as people started understanding the potential of a computer, the microcontroller, microchips, etc. And it started embedding into the machines, and you got CNC machines, that is using electronics and computation, everything. And you became robots, you got CNC machines, you got, and all those things. So that's the industry 3.0. And comes where you can see at the same time IT also started coming up, the mobile phone started coming up. And what happened is, as you know, mobile phone is started from 2G to 3G to 4G. Now again, once it comes to 4G, then you got IT coming, controlling everything, the information technology controlling all these gadgets, all these things. So now you are able to run a machine, everything through a smart app in your mobile phones. That is industry 4.0 using cyber physical systems. That is 4G. Now already we are into 5G. So 5.0 also arrived, industry 5.0. So that we are going to discuss in next slides. So industry 4.0 talks about how you integrate all these heterogeneous systems using IT and enabling to run through a smart app, etc. And you are able to run heavy machinery, need not go to the machinery physically, but you can run it through your mobile app. This is industry 4.0. So as our Honorable Prime Minister Narendra Modi sir said that in Davos, that industry 4.0 is not about robots, it's about humans. Again, we should all understand that we all carried away by the technology, thinking that technology is going to be the, what you call, the means of everything. But actually the technology is controlled by humans. Until the human touch is there, no technology has got survival and no technology will flourish. So that's why our Honorable Prime Minister said that Industry 4.0 is not about robots, it's about humans. Definitely we should understand the inner meaning of that sentence. So it's a name for the current trend of automation, definition of Industry 4.0 and data exchange in manufacturing technologies. It includes cyber physical system, Internet of Things, cloud computing and cognitive computing. So it talks about smart factories. You are able to run. Now, most of us think that Industry 4.0 is only for industries, but now this technology has also come into home automation. You might have seen nowadays smart homes. So especially in a gated community, everything is controlled by your mobile app. You can open your home with a mobile phone. You can monitor who is coming and going out. You can switch on your geyser. You can switch on your AC, you can switch on everything through your mobile phone without present in the home itself. You can start from your office. While coming from the office, through a smart mobile app, you can control your AC, you can control your what you call mobile the sweeping, that is a cleaning machine. You can operate your dishwasher, anything. So that is industry 4.0. Doesn't mean only smart factory. It talks about your home automation also. These are the building blocks of industry 4.0: autonomous robots, simulation, horizontal vertical integration, industrial internet of things, additive manufacturing, augmented reality, big data analytics. So all these are the tools which are part of the industry 4. That's why artificial intelligence, machine learning, and all these things are becoming very popular. And in that, additive manufacturing is also one of the important tools. So we are going to concentrate on that. It is also popularly known as 3D printing. I hope I need not tell the definition of additive manufacturing. Already yesterday you might have got the inputs. Or nowadays it is commonly known everywhere. It is nothing but a technology that produces models and prototype parts from 3D CAD model data, CT MRI scan data, or model data created from 3D object digitizer system according to Terry Woolers, or according to ASTM International F42 Committee. Is a new process of joining metals to make objects from 3D model data, usually layer upon layer, as opposed to subtractive manufacturing method. That's why it's called additive manufacturing. It is also called positive manufacturing, or it is a part of sustainable manufacturing, where the material loss is less when compared with the conventional manufacturing process. These are the basic steps in additive manufacturing. Like, first you have to create the CAD model, then convert into STL file. I am not going to spend much time on this because already you know. I am hoping that you know all this process chain of AM. Then once you convert into STL file, standard triangular layer information, that means nothing but converting into number of triangles each layer, then slicing it to number of layers. Then that each layer information is fed to your software, where you are going to send that one from the STL file. Once you create in any computer, you send it that file, transfer to the computer which is attached to the machine, and then you do the machine setup, like what should be the layer thickness, what should be the build orientation, what type of material you are going to use, what is the laser diameter you are going to use, laser intensity or infill density, all this machine based on the technology you are adopting, whether it is a powder bed fusion technology or whether it is a wire fuse deposition molding technology or binder jetting technology, anything. Based on the different technologies, you are going to set up the parameters. Then you start building the part. Then once the part is built up on the build bed or build platform, you remove the part, then do the post process, and finally develop the application. So let me start my journey of additive manufacturing with the biomedical case. So up to now, you have any doubts, anyone can ask, because online lecture, I don't know how many of you are attending this seriously, but you have any doubts, you can ask. Okay, right. Now this digital manufacturing is also known as additive manufacturing. So I'm going to start with biomedical field. So I'm going to talk about 3 cases: orbital volume, cranioplasty, facial asymmetry, and 4 cases: facial reconstruction. How I can use additive manufacturing biomedical field. AM became very popular in biomedical applications because nowadays, if you see any doctor, they know more than us. Most of the doctors know additive manufacturing. I know one doctor who recently published a book on orthopedics. His team is orthopedics. He published 3D printing, application of 3D printing orthopedics. Dr. M.V. Reddy and his team from Sunshine, they published a book on it. I'm really surprised to see doctors using this technology a lot. So I'm going to share my experience where I worked with these doctors in doing these several interesting cases. Worked with this doctor. These are live case studies. So, you know, the doctor and engineer now has to join hands because we have to solve number of problems, number of critical surgeries the society is facing. That's why we both have a synergetic effect. I call doctor as a god I call engineer as a weapon in the hand of the doctor to kill the demon that is a disease. So we have to now join hand to solve this one for the betterment of the society. You can see, observe any of the healthcare sector industry. If you see, when you go to a hospital, you see all these gadgets. So who developed these gadgets? The engineer. So the engineer developed, and especially today is, I don't know, it's coinciding, it's an engineer's day. So my wishes to all, happy engineer's day, right? So it's an engineer who is now working with the doctors in making our lives very comfortable. He is the man who developed the CT scan, he is the man who developed the MRI, he is the man who developed all these tools, but finally it has to be authenticated by the doctor, right? The human touch is by the doctor only, not the machines. But definitely, we are going to help the doctor in giving better treatment, a quality treatment, and a correct diagnosis. So we became an additional hand to the doctor or to the surgeon. Why 3D printing became popular in medicine? Because you can make a physical model. So seeing a X-ray, most of us don't understand what is X-ray, except the medical professional. Most of us don't understand it. So to communicate to educate a patient, a doctor can use a 3D printed model. And diagnosis and surgical planning. And planning a very complex surgery, I am going to show some cases where they use 3D printing before they perform the operation to plan their surgery. They may not be using directly the 3D printed model in the human body, but they may plan, they may simulate the operation on this model, prototype model. They get more confident, then they can go for the real-time surgery. Rehearsal and simulation of surgery, creation of customized prosthetics, and accurate placement of implants. So these prosthetics and implants are something most of we buy, patients buy the prosthetics or implants, mostly generic in nature. That means they are not exactly related to that patient. They are generally available outside, they buy it. But when they fix to this patient, whether prosthetic or implant, it may not be accurately fixing to it. There is a lot of inconvenience. Now trend is now slowly shifting to customized prosthetics and implants, where it will fix exactly to that individual customer requirement. So there, additive manufacturing is going to play a very important role. Additive manufacturing brought a change from mass production to mass customization. That means earlier you are producing things of the same model in large number, but now people don't want to have the same model of the car, same model of the cell phone, same model of my laptop. I want to have my customized models, but I should not take more time making it, and I should do it very fast, and I should produce without any compromise in the design or quality. So the technology that is going to do help in this process is additive manufacturing. That's why additive manufacturing became popular in customized prosthetics and implants. The transformation we brought is from a X-ray, 2D X-ray to 3D model. Let us see how we use additive manufacturing for orbital volume analysis and mid-facial fractures using 3D printing technology. So what you are seeing on the screen, a person who got injured on the left side, on the right side of his eye. This is for me when I am seeing it's left, but other side it is right. So he got fractured at this point. This is called zygomatic bone. When the fracture happens now, this area you call orbital volume, this gets enlarged, because of which his eyesight changes. You see the contralateral side, that is where is unfractured side, nothing, there is no damage here. So you compare this volume with this volume, how much change it happened. So doctor will now perform operation, take all these bones, etc., and fix that and perform the operation, and you get, and you try to restore. But in my case, I am going to talk about how much the restoration happened after the operation. We want to tell the doctor, this is your operation procedure, because of which you are able to restore only up to this extent. Or you can suggest, this is the way, if you perform the operation, this is what happened. So once we give this input, he will try to improve the operation procedure and improvise it so that he can restore to the near to the original one. You cannot make 100%, but at least you can reach from 92 to or 90% to 93 or 95. A 2%, 3% increase in this restoration has got a lot of satisfaction for the patient. I'm going to talk about this live case study. So this is a part of my UGC minor project which I would have done. So coming to this one, this type of accidents happen due to motor vehicle accidents or due to a sports like boxing, you have a punch hit here or any accidents, anything, the fracture happens like this. So this is, if you just go to the terminology, just remember this is a zygomatic bone which joins this lower one, your cheek, and the upper one. It's a very delicate one which breaks whenever such type of accidents happen. Right. So in this, what we have done. Now, the doctor, now they also have on human body landmark points. So like we engineers have datum, we select a datum, from there we do everything. So in this kind of fracture, we have four landmark points. Supraorbital foramen, please observe my pointer. This is called infraorbital foramen. This is the zygomatic frontal suture. This is the medial orbit. So these are the landmark points. So once we get that model built, no, then you can first measure the unfractured side. What is the distance of them? You can calculate the volume of this. This location of the landmark points is done by the doctor, not by us. But we will be printing from the CT. I am going to tell you how we have done this printing, everything done. In the next slides, I am going to explain them. But just you observe that they are going to have four landmark points here. So we have took a 20 years old. In fact, we have done such type of thing, 10 to 15 case studies. So I'm just presenting one case study, 28 years old male patient with in collaboration with the SVS Medical College, Mabunar, we have done. So this is the person who got this injury, left lateral view, frontal view, and right lateral view. Then we have taken a CT scan image. We have developed this 3D model using medical imaging software. Then we produce the 3D printed skull, FDM skull. And we have done the evaluation of the orbital volume, and we have analyzed and validated the results. So for this, we have used different softwares in our case. So this is the DICOM image we are given, digital image communication medicine. This is the first input for us when we develop the biomedical model. So when you take this DICOM file, you put input into it any of the medical imaging processing software, like you have Mimics, you have Invatchless, you have 3D Doctor, you have 3D Slicer. So many softwares. Some of the free softwares are there. Some of them are, they have to purchase them. So like you have Invatchless, it is a free software. Or 3D Slicer is a free software, but they have some limitations. But otherwise, you take Mimics, they are high-end software. 3D Doctor, they have very high-end. So that's why they are not free. You have to purchase them. So you take any of these softwares. Then what happens in that software? Once you import the DICOM file, no, it will be processing those images. So when you process the image, when you take a CT scan image along with your region of interest, for example, I'm interested to know about this front skull fracture. When you take this, no, I get skin also in that image. I'll get other things also, other part of the one. For example, taking on head, along with the skin, you get hair, every other thing, right? So when you get this, you have to remove that unnecessary reason. So for that, what happens? This is called thresholding. What happens is, for every image, you got pixel value. So right, so pixel value for bone is different from pixel value from the skin or some other thing. So your region of interest is bone. So when you select the pixel value of that bone, that other things will get eliminated. So then you select that region of interest and grow it. Then you build up the model. So right, you can see here, these are the various software we used here. The 6 out of 6, 5 are free software. Strata 1, Maxla, we use the trial version. So let me tell you how we used all these three softwares. So first we have taken radiant DICOM viewer. As soon as we got the DICOM image, we put and see the quick overview of the 3D model of the CT scan, such that research can be carried out over the specific area of interest once we get here. Then we have used the DICOM file. We imported Invatchless software, open source software again, and we developed this one. You can see the image, step 1 medical image. You can see, like our engineering also, in doctors also, they have front view, top view, and side view. The front view is the coronal plane. Please observe here, front view is the coronal plane. The side view is the sagittal plane. And the top view is the axial plane. It's only we both talk about the same thing, but in different terms. We call front view, top view, side view. They call it as what they call it as coronal view. They call it as sagittal side view, and axial is the top view. You get 3 images like this when you take it. Then you grow that region. Then what happens is, as I said, thresholding, everything you do, and segmentation, remove it and do grow the region. Then you get this image. 3D image you get isometric view like we get in other models, we get like this. Then we try to convert a STL file, but when you take this now, you got a lot of discontinuous areas you will get here. Then you have to remove those unwanted regions, cleaning of unwanted regions you have to do. Then we use the Blender software. This is a free software again. Open source software you can use, Blender software you can remove, and by using different methods, different steps, you can remove the discontinuous areas. So like this, we follow different steps and remove the discontinuous areas. Then after removing the deleting unwanted region, then what happens is you should again smoothen those things. For smoothening that, we use mesh mixer, so that wherever you lost the discontinuous areas are there which you removed, you have to smoothen that we use mesh mixer software and make that one. And then once you do it now, then you get these things. So inspecting and repairing errors on the STL file using Autodesk mesh mixer software. And then you repair the errors, etc. You do it. Then we import that file into the Flash Print software, which is the software which is attached to 3D printer, which is attached. So you import to that one. Then you print. You have to select which direction you want to print, which orientation. We selected this 270 degrees plane X rotate 270 degrees. It reduced time 21 hours 16 minutes. And metal consumption 41.52, and then we produce that model. You can see while in the flash in the FDM printers, Cura also you can use. So I use this. I am using Flash for 3D printer. That's why I use Flash Print software at that time. This is way back done, I think during the Corona time, before Corona time. So we improved, estimated, and printed this using this printer. Very small printer, but does a lot of work you can do. And we have started printing this model. This is before, after the accident happened, and before the operation. Before the operation, after the accident happened. So this is how it appeared, the fractured, and a 3D model. So if you see this in X-ray, you will not understand much. But the doctor we have given this to him before the operation. So you understand how the fracture happened, everything. Then he planned the surgery. Now what happened is here, one model we printed. Now what we'll do is we'll measure the landmark points of the unfractured side. This is called contralateral side. We measure this volume. Then same landmark point will be marked by the doctor before operation. The fractured side. What is this volume? You can estimate. Then again we started using the after operation, we collected the again CT scan image DICOM format. Then we started printing not the entire region, but only the operated region. Because other side there is no change. Only this side we started printing, this side where the fracture happened. So this we printed only half of that, and then we measured again the land. See how after 3 months time how these osteogenesis happened. These are actual mini plates, titanium mini plates. So you can again they measure the landmark points and they measure this volume. So with this, now we are able to estimate what is the change in the happened in the volume before operation, after operation. So we measured these landmark points using the vernier calipers. You can better use a CMM machine. At that time we could not use it. But you can also measure digitally by using Maxlow Strata1 software. This is a very high-end software, very costly, but we got trial version. We measured this, and you can see in the software, you can directly see this is 27.0861 cc is the orbital volume of the unfractured side, and the fractured side before operation is 29.7710 cc. That means this is the amount of volume that increased here. Now once you do the operation after 3 months, we measured it is 27.3350. On the digitally, you can see the original one before operation is 27.0861. Assuming that the contralateral side volume is same as the fractured side volume, but now after operation you are able to bring it to 27.3350. That means you are almost reaching to that one. But 3D printed one also we measured, compared it. So what we conclude from the above results is that the orbital volume of the unfractured orbit, fractured orbit before operation, fractured orbit after operation is found to be 21.04 cc, 29.04 cc, 21.699. And the operation, they are able to achieve 92%, almost 92%. It's a good sign of restoration, but there is always a scope for improvement. This is what the first case study we told doctor. Like this, we are not done only one. We have done around 10 to 15 cases. Then we have done all the mean calculation, statistics, everything we have done. And like this, we told the doctor how effective is his operation, how best you can improve his operation procedure so that he can improve better and you can perform in a different way so that you can restore it to almost 96 to 97%. So using Stata1, it is only 90.0667, but 3D printed model you got better because in a 3D printed model you can effectively locate the landmark points, which is difficult on a digital model. So let me come to the next case study on cranioplasty surgery. Why I'm telling all these things is that you should know the topic is challenges and future trends in AM in industry 4.0. Unless you know the application, you cannot understand what can be the challenges that I'm going to discuss in the last slides. So cranioplasty surgery, surgery to cover an injured bone in the skull. So this man got injured on the left parietal region of his skull. So you have to put an implant to it. So what happened is this is a skin they simply stitched on his on his head, and there is no supporting here. So we developed implant for this one. So what happened is before this 3D printing, how they used to perform operation, they used to remove this hair completely, put a basket, take algae, apply on it, and using hands, it depends on the expertise of the surgeon. They used to see the shape, how the shape of that one that fractured happened. So this is then based on this, they used to develop the implant. So here our task is to remove this step completely instead of making the patient to see to suffer for 6 to 8 hours in getting this one. We have to remove this step. So for that, what we have done is we have now asked the doctor to give the CT scan image, and then as I told, thresholding and taking segmentation, everything. Then we develop the digital model of this bio model you got. So now you know this how the fracture happened. Before here patient is required only to get CT scan, not for removing his hair, all those things, and making him to get the impression how the fracture happened. This step is eliminated now. Right. So now you can use this, and then the doctor said, please print the entire skull. So he said, we can do, but it's very costly, because doctor was thinking now he will take this printed skull, and on this he will apply again algae and get the fracture how it happened. But we told it's not required to make the entire skull to be printed. You can use a command car mirror and you can get the replica of this, assuming this side is also normal. You can get this, and we got a digital model out of this like this. So the cost comes down very easily. Now remember here, in this operation, we are not making implant. We are making the model of the implant. We are making the model of the how it appeared out. So this is actually made with PMMA using our SLS technology, selective laser sintering, which we have in our center. We printed this model using Formiga P100. This is what we made before the operation and given to doctor. This is how this impression. As I said in the earlier case, using the algae applying on the head. So that what happens is there it takes a lot of time. But now with the 3D printed one, you can produce very fast and you can show it to the doctor. Then he will trim, and according to the requirements, he will make the implant bio in a indirect way. This up to this step only will be here giving this to the doctor. I am telling this indirect rapid tooling it is, given the pattern, and they make a mold out of it in their own method of biomedical, taking all the precautions, everything. They make a mold, and in that they pour polymethyl methacrylate, biocompatible, very common use compatible material in all these implants. They used it and they finally fixed it to the patient. You can see this is the original bone. This implant you join with the titanium mini plates. So this is what you can see. So this is a very we had done in 2013, I think 2000 some almost 10, 12 years back we have done this, and we reduced the operation time by 22% operation time. So we got certification from CARE. Like this, many of such complex surgeries, sometimes you get both sides injured. So there you cannot use mirror command. You have to go back to your basics of CAD modeling, develop a Bezier curve, B-spline curve. Your complexity increases, your time taken for modeling increases. Most of us think that what is 3D printing? Simply you give the model, it will print. But actually 3D printing, the most complex step is developing the CAD model itself. The first input step is the developing CAD model. If the CAD model is not developed correctly, the output is going to fail. It's like garbage in, garbage out. So you have to spend a lot of time in tolerance, everything in developing the digital model. So you can mirror, you do all these things. You can use a spline curve or B or whatever the required, you can use it and you can produce this. So we even use for FDM technology we use, but when compared to FDM, SLS definitely gives better accuracy, everything. So you can use 3D printing in in so many parts of the human body: cranial prosthetic, surgical guide, scapula prosthesis, knee prosthesis, dental implants, interbody fusion cage, acetabular cup, and hip prosthesis. In fact, we are now working on developing patient-specific acetabular cup with DMRL and with Dr. M.V. Reddy Sunshine, working on developing this patient-specific acetabular cup. These are various technologies that are popularly used in additive manufacturing, like selective laser melting, select SLS, LDMB, or selective electron beam melting, all those things. So another case study is this girl got her injury face got not injury, is her lower mandible got dislocated. This is called facial asymmetry. Facial asymmetry is where you think that left, right are same, but actually left and left, if you know, if that's symmetrical, then it appears like this, right and it appears like this, but you are like this. So everyone has got some facial asymmetry, but that is negligible, you cannot notice. But some people that asymmetry is big, then they don't, they'll very psychological depressed. So we asked doctor how they used to perform this operation before 3D printing. They used one method called cephalogram model. Now, what is cephalogram? They take X-ray in front view, top view, side view, and as I said, they put a trace paper on it, select the landmark point, measure the deviation. So you take front view, you take side, top view, side view, and everything. You measure all this deviation. Then finally, you extend this deviation a third angle, third space that is imagined by the doctor. So remember here, doctor input is only 2D maze, but he is going to imagine those in the 3D on his own. But when he performs operation, he is not performing on 2D, he is performing human 3D body. So once he opens, he find it difficult to locate what he imagined may not be exactly fitting into it. So what doctor asked us to please develop this 3D model before the operation is done. So as usual, we took the DICOM image and we modeled this. Mandible we have modeled and we printed it, and we before operation you measured how much is this deviation. Then the fixed he knows exactly during the operation how much he has to shift that one. He shifted, and this is what you can see the result after surgery. So this is how additive manufacturing plays a very crucial role in all. Most of us think in developing directly implant. It may not be used for directly for developing implant. You can as well as use a simple FDM technology for doing planning the surgeries, my critical surgeries. So this is the biomedical. Let me go to the aerospace applications. I am going a little bit fast because time is running out. But if you have any doubts, you can stop me and ask. Am I with you? Are you with me?
Sir, we are with you, sir.
Yes, sir.
I hope I am not boring you.
No, sir, not at all.
Okay, thank you.
No, sir.
Yeah, right. So let me speak about these aerospace applications. Another interesting area where additive manufacturing playing a very crucial role is in aerospace application. So what we developed in 2016, we made this prototype model of a CubeSat model, entirely 3D printed, entire thing. Now, India used many of these additive manufacturing parts in its Tejas lightweight multi-roller jet. And now NASA is developing the rover, which a pressurized cabin to support astronauts. And they used 70 FDM parts they printed. And you can see recent expedition to Mars by launch of the Perseverance rover. And even our Chandrayaan-3 mission used used not directly, they used on the model, but they simulated thing on the Earth. For that, they use 3D printing a lot. So ISRO also adopting this technology a lot nowadays. So SpaceX, they use this technology in many of these applications. So this is a space vehicle NASA building up using this technology in all these parts, the rover part, etc. Similarly, in our own Tejas aircraft, they used 2,500 parts in the Kavar engine prototype, and test engine at the Aero India they reduced, and it was observed by Dr. U. Chandrasekhar that is at the time is the director GTRE, Gas Turbine Research Establishment. So they found that the cost reduced from 60,000 to 20,000. The time is 12 months to 1.5 months. So like this in Perseverance also 11 metal parts are printed. In earlier they launched Curiosity rover, they model everything using on the Earth, and they tested everything, the prototype model. Once they found correct, then they launched it to the Mars. So in the Perseverance model, they developed 11 metal parts using SLM technology and other things. So heat exchanger, Perseverance MOX instrument they used, and even the Mars Curiosity. So they model all the parts and assembled it. And even as I said, we use this nano-sighted structure 3D printing. I got the opportunity to present in the ISRO conference on large-scale multidisciplinary system of nation significance. So nano satellite, you can see this is a very small satellite used for specific purposes, 1 to 10 kilograms. And we use this the input CubeSat design from California Polytechnic State University, and then we model it, define different structures. So you can make different models, single piece CubeSat concept, modular rail design, but we adopted pumpkin structure and made it using 3D print. So you can make all the racks on this, you can put all the piece and launch the vehicle with proper packaging, etc. So you can use 3D printing for many of these applications. Similarly, micro air vehicles you can make nowadays, drones you can make using 3D printing. In now Chinese firm, they use Forsen technology, use SLS, and as its primary method for metal 3D printing. Even our ISRO also recently made an engine using 3D printing. Startups in Hyderabad, some of them participated in that. So 3D printing is got a lot of potential in aerospace applications. Coming to agriculture field, you imagine you have got a very big ploughing tool you got here, and some small part is missing due to some breakage or some worn out. So then for that small spare part, you have to wait from the OEM person to get the spare part and get it. Otherwise, this big part will not work without that small part. So waiting for that small part from OEM takes a lot of time. And for example, in Corona time, the supply chain breaks. So in that case, if you have a nearby 3D printing technology is available to you, a small startup company, they can scan that old worn out part and it can develop the digital model and print that and just put it to this and make this big one to work. So 3D printing has got many potential applications in agriculture industry, definitely, because agriculture is the backbone of countries like in India or China. So most of the population still uses agriculture as its daily life, and they produce a lot of things for all of us to live happily. So we have to help the farmers. So you know, one company in Italy started this urban farming concept where you can grow the plants, eatable vegetables, etc. You can grow in your home. So they call it as hanging gardens. So they made 3D printed connectors to increase the size of the garden. So this, you can see this video.
Have you ever wondered how to
Are
feel
you able to
closer
hear
to
the
nature in your house?
audio?
This is the living farming tree,
Yes, sir.
a uniquely designed plug-and-play system to grow food anytime, anywhere.
Yes, sir.
Insert the bars and the connectors, place the farming modules, and transplant your seedlings. Plug the system to electricity and connect to a Wi-Fi connection, download the app, and you're ready to grow. Through its modular sensors, the living farming tree will measure several parameters in your house and will automatically adapt the system for the efficient growth of your plants. When the system is in need of attendance, it will send push notifications directly to your smartphone. Use your smartphone to plan your crops, monitor your system's activity, and gather information to share with your fellow urban farmer friends. Easy to unpack and assemble, you will be able to adapt the living farming tree to the space available in your house and start producing delicious, healthy food with just a few clicks. The cities of the world host over half of the global population. By 2050, this number is expected to grow up to 80%. Who will farm the food we need to feed our planet? Collaborative urban farming is a regenerative solution to decentralize food production, enhance its supply chain, and increase food quality within cities.
Like this, you can use 3D printing for making drones for pesticides. You can as well as use this type fruit triclaw fruit picker. So you want to use it for high-end trees which are very very tall trees are there. You most of the time they climb up and pick the fruits, etc. Instead of that, you can make a long wooden stick on the end. You can make this a 3D printed triclaw fruit picker. You can pick that fruit and you can now save the lives of the farmers you climb up, and you can also get productivity increased. Similarly, sprinkler with more watering capacity like this one can be used for crops like paddy, rice, potato, and soybean. As I said, we made this type of octagonal nozzle. We made different models like circular nozzle, octagonal nozzle. We have made other hexagonal nozzle, etc. Found out which is the best nozzle. This top one we printed using SLM. This one we printed using FDM. So both we combined and then we used it. So we got a better result with octagonal having more wetting of the area. So like this, you can go on using 3D printing for many agriculture applications. Like sports industry also, you might have seen this stuff. Yeah, any questions? Okay. Sports application, this type of wicket system is called zinc wicket system. Nowadays used in all formats of the cricket. So this is developed by an Australian mechanical engineer. So these stumps became very famous. So this by Bront Eckermann, and you develop this one 3D printed stumps. Now you find a lot of application of it because it gives help in making correct judgment. Earlier they used to put only mics. Sound travels slower than the light. So for a third umpire to make a decision, this light once it glows immediately, whether it's run out or not, etc. You can immediately judge. So technically you can help this umpire in giving a correct decision. So that's how these terms became very popular from 2015 World Cup onwards. Now it is used in all formats: T20, Test match, One Day International, or what are the formats of game you have. In all the formats, this became very popular. So sports application, you find Reebok developed the liquid squid shoes. All this you can see the outside, this particular mesh type thing. This is designed for distance running, cardio workouts, and comfort. This is called liquid drawing. So pneumatic material extrusion via robotic arm. So this will help the athletic to run faster. And when running also, certain amount of energy is going to be on the ground. So when the shoe hits the ground, it absorbs the energy, then returns it back. That's high bound. So that's how it helps him to run faster. Similarly, most of the famous shoe making companies started adopted this style, like Adidas, Nike, Under Armour, New Balance, Reebok. They use DL, direct light sintering, SLS, stereolithography, material extrusion process in making different parts of the shoes. like customer products, midsoles, uppers, other parts. You can watch this video right from technicals. In entertainment industry, it is used in many of these popular hit films. They use this technology in different places, like a studio called Legacy Studio. They use this technology for making various movies. Yeah. The link is lost, I think. You can see in creating this Iron Man suits, they use FDM technology. Similarly, in this movie also they use for making these night goggles replica of the original thing. In the movie, they cannot buy the original one, which costs around 60,000 US dollar. They made a replica of this and put it in the movie so that it looks realistic. Similarly, the weapons used in this film, all these popular Hollywood films, they use 3D printing. So even our Bahubali set was made and displayed in Mumbai-based Softotech. So like this, they started using 3D printing in many of the movie and entertainment industry. Coming to the food processing industry, you adopt this technology like binder jet, powder bed fusion, metal extrusion, and indirect mold methods. So these are the reasons why it became very famous. But challenge in 3D printing is material that you shape, stability should be there, traditional food rheology should be there, and safety, etc. So NASA used this technology and going to use this technology in 3D printing food for its next space expedition to Mars.
US space agency NASA is funding a company to develop 3D printing of foods. Advocates of 3D printing technology say delivering long-life foods from alternative ingredients could help solve the problem of feeding astronauts and ease food shortages on Earth. Manned space missions require stocks of non-perishable foods. 3D printing could be a promising solution to the problem of feeding crews. Traditionally, food sources perish easily. Proteins, vitamins, fibers, and carbohydrates can be derived from alternative nutrient sources like insects, grasses, algae, and seeds. Stored as powders, they can last for years. When combined with sugars and oils, nutritionally dense.
So like this, you can use in many of the applications. In jewelry industry also, people are using this technology, indirect way of making jewelry. Like you can make this pattern using 3D printing, like most popular technology jewelry are SLA, DLP technologies, indirect or FDM also. You can make them 3D printed model. You can assemble all the rings like this. You have number of rings you can assemble in the tree. Then you dip in the slurry, get the shell building out of it. And then these patterns are 3D printed on with wax patterns. So like SL, you can jewel cast like this different wax pattern. And then once you heat, that wax melts away. Then pour the actual gold and you get the required shapes of the rings you can make. So 3D printing in investment using an indirect way. This is what you can see. Similarly, we use this in our lab using SLA DLP technology we used and printed this rings we made using this technology. So they made with jewel cast. We made silver jewelry out of it. So in our lab we have done this 5 Pro 1000 we used it. Similarly, there are various. Now you can also use direct printing of jewelry using powder bed fusion technology, DMLS or SLM technology, but it is very costly affair. People, that's why most of you will go for indirect way of 3D printing. These are the models used, and these are the famous software. You have Jewel CAD, one dedicated software jewelry applications. Automobile, you can make all the parts using the 3D printing. Car bumper, tail lamp, car dashboard, functional ducting, rear wiper, motor cover, and ORVMs, whatnot. Many of the applications, all these the automobile sectors are using this. So because these are the technologies which are used, SLA, SLS, for making various parts of the automobile, and these are the various popular materials used: nylon, resin, metal, and all those things. Similar electronic applications, you can use this all the parts. You can see headphones or your remote or your horn antenna or whatnot, the casing of your mobile phone. So we used in our lab. I worked with electronic students, use the SketchUp make software, build a horn antenna, produce it, and we use it for communication purpose. Like this, you can use inkjet technology or aerosol jet crossing, 3D print technology in most of the electronic application. Even you can make the entire phone and the printed circuit board also you can make using 3D printing. So you can use it for civil engineering, for making the model of your building. I have done my arts college building. We have 3D printed. We have 3D printed our engineering college model also. And you can, as well as in US, one company printed. This is what we have done in our during our centennial. We developed this memento of our Usman University Arts College, very iconic building, historical building. We 3D printed. We don't have any drawings. We measured it. Our engineering students measured it, and then our mechanical student developed the model, and we printed that. So using this printer, 3 models, then we assembled them, got this part. So you can make before you build the Olympic village, you can model everything using that one. So this is what you can see. So this is a building which is developed by L&T in 106 hours in Chennai recently. So 3D printing in civil engineering lost very big applications. People are now using it for many, and you can do for what you call group housing. Many, like government has got many schemes to construct houses for the underprivileged or lower income group people. So for making this in a conventional method takes a lot of years, but using 3D printing you can make this very fast. Similar interior design, you can see nowadays in many malls such type of shapes. You can 3D print using this technology. A lot of demand is there in interior decoration also. Like this you can see. So after telling so many applications, I can go on speaking with many more applications. But what are the challenges that you are facing in additive manufacturing? Now, additive manufacturing at present don't have any benchmark standards like you have. Now people are developing recently, but still like AICTE standard for this, that is still is under process, and you don't have a lack of standardized process, and expertise availability is very less. In India, no, recently, our center has got, in our university, we also got National Center for Additive Manufacturing, which is on this process of improving the skills and training all our students in additive not only students or faculty, everyone in this technology. They find that lot of applications required, but very less trained people are available in these IEM technologies. So this is one challenge that we have to face. And now that's why in Government of India thrust area also additive manufacturing, one of the area like AML. So additive manufacturing expertise should be improved a lot in countries like India, where there's a good educated students are there, very youth is there. So that there's another one challenge. And how to control the quality and product quality. That is another area because there are a lot of, even I am telling so many things, but still we have some defect like porosity comes in the picture, or how far the dimensionally you are accurate, and what is the effectiveness of your process parameters, etc. That is one thing. Other one is the cost. Cost is still higher than the conventional method. Where to use this technology, where not to use. don't think additive manufacturing is going to replace the conventional. Actually, additive manufacturing is going to be a value addition to the conventional manufacturing process, where you can use this technology to develop a product very fast. You cannot imagine all the parts of the product are made with additive manufacturing. Sometimes the conventional works better than the additive manufacturing. Other one is the sustainability concerns, environmental effect of additive manufacturing, because this is the most important concern everyone should think when you develop a new technology, how it is going to affect the environment. In fact, one of my students, we have worked on that one. I'm going to tell one case study. And future trends in AM in Industry 4.0 is AI and automation integration are happening. So how you use AI in integrating, making the additive manufacturing machines a smart AM machine, focus on sustainability, human machine collaboration. This is what is Industry 5.0, that is 5G. You are going to have this, more work is going to be there. And advanced material development is another, that lot of demand for new materials for additive manufacturing is there. And real-time monitoring of digital twins. This is another, digital twins is become very popular. So how to monitor the real-time happening, that is another challenge. Future trends that is going to happen in AM Industry 4.0. This simply, we have compared producing I am talking about sustainability, a rocker arm. It's already we published a paper using additive manufacturing conventional method. I don't want to tell in detail all the things. Just you can refer to my paper. So in LCA life cycle assessment, we have considered gate-to-gate process and compared between the conventional method and the additive manufacturing method. These are different stages in LCA, you can see. And so there are different definition of goal and scope, inventory analysis, impact assessment, interpretation. And so there are, we use a software called SEMA Pro software for life cycle assessment. And so you have three things: midpoint impact category, damage pathways, and endpoint area protection. We consider damaged human health, damaged ecosystem, damaged resource availability. What we found in this research is we have considered like this calculation done. So because the time is exceeding, I don't want to explain this, but I'll show the final thing we have done here. The rocker arm, solid rocker arm, produced by conventional method, produced by additive manufacturing. But then we use topology automation to change this rocker arm, and we produce the topology automation part using the additive manufacturing, because conventional manufacturing is difficult to produce such shapes using topology optimized part. So to our surprise, what we found is conventional manufacturing has got less effect of the environment and compared with additive manufacturing. If both are made with solid, that means solid rocker arm with additive manufacturing has got more environmental effect than the conventional manufacturing process. But once you do topology optimization, that you are able to produce the rocker arm with the what you call with 3D printed method, that has got less effect when compared to conventional manufacturing. So what is the thing that you should understand is additive manufacturing is very good when you go for very complex shapes, when you cannot make using conventional manufacturing method. In that case, additive manufacturing method has got more advantage than the conventional manufacturing method and less impact on the environment. This just I want to tell. This is a damage assessment you can see here. So ecosystem, rocker arm by AM, rocker arm by AM with optimization, with topology automation, and rocker arm by convention. So you can see this graph will clearly give out that rocker arm by AM with topology optimized part has got less environmental impact when compared to the conventional or rocker arm without topology automation by additive manufacturing process. So what is the idea? What I want to specify here is, don't simply carried out by additive manufacturing. Additive manufacturing is very much suitable when you go for a very complex object which cannot make with the conventional manufacturing process. Definitely is going to have less impact on the environment. So these are the future trends of AM as per the Gartner's curve. So we are in the, initially it got a lot of peak in the initial stage, innovation trigger, then peak of inflated expectations. A lot of people got, but later they found a lot of defects. So it came down trough of disillusionment. Then finally, the limitations are overcome. Now we are in the area of plateau of productivity. So it is going up in many of the areas which you never imagined. 3D printing is going to work like anything, but I'm again putting in that whenever the complexity is high, wherever you can afford for most complex things, you can cost of the technology also coming down. So 3D printing is going to be very popular, but don't think that it is going to completely replace the conventional manufacturing. Still, conventional manufacturing process has got its own demand, but additive manufacturing is going to add value because we shifted from mass production to mass customization. When you talk about customization, definitely additive manufacturing is going to have a lot of demand when compared to the conventional manufacturing. So there are a lot of opportunity, government funding, a lot of Ministry of Electronics is giving a lot of support in doing projects in additive manufacturing. DST also, I think this, some of you might have already applied this, and you can, a lot of journals are available, you can do a Q1, Q2 publications, etc. So I acknowledge all my team of doctors who worked with me. I thank my students who are with me in all this research. Thank you all for your patient listening. Late evening, almost it's night. If you have any question or answers, you can ask. This is my contact information. Thank you.
Yes, dear participants, if you have any queries, then please
I hope
put in the
most
chat
of
box.
you are with me or some of you left. I don't know. Any questions you can post in the query box, or the coordinator can ask the questions. Any questions from the audience?
Hello, may I, sir?
Yeah, please introduce
Yes.
yourself, madam.
Sir, myself is Dr. Priya Shinde. I am from Jawaharlal Nehru Engineering College, MGM University, Chhatrapati Sambhajinagar, Maharashtra.
Great. Please.
Sir, I have one question that when we think or talk about today's generation, the students which we call Gen Z, so what kind of challenge they are going to be faced for 5.0, Industry 5.0, and how they should get prepared to face those challenges?
Industry 5.0. Right.
Yes, sir.
Yeah. So Industry 5.0 means you have to update your integration of the technologies plays a very important role, madam. So how to use AI with your additive manufacturing? How do you develop a smart 3D print technologies? And how you can use it for multidisciplinary applications, right? So it's not that I am a mechanical engineering, so I'll be doing only the developing. You also start thinking about how I can train my samples which I produce, or how can I store in a database, in a huge big database, and develop the algorithm so that instead of making every time those models, you can as well as predict the models using AI. And once you say this model is good, then you can only print that one using additive manufacturing. That means this concept of integration should happen a lot in the next Industry 5.0, where you will be having various scenarios. But that's why your bandwidth increased, and you have a lot of multi-agent technologies coming up picture, and that type of skilling that you should do. So how to adopt this new thing to our, because 3D printing is now everyone knows about it, but now how you make things to be very fast, smarter, very fast, that you should have the understanding. That way your course curriculum should be developed, madam. It's not that I teach only to mechanical engineers, but in fact, I teach this subject as open elective for other branches. So in my class, it will be almost 150 students are not from mechanical, they are from electronics, they are from biomedical, they are from computer science, AML, so many people. everyone has got some different ideas. So how to make them to use this technology in their era. Similarly, a mechanical engineer should learn AI tools, because how they can make these machines more smarter. So with different tools, not only AI, you should know knowledge of big data analytics. It's like master of one, jack of all. You should.
Okay, sir. Thank you.
Thank you. I hope I answered your question.
Yes, sir. Yes, sir. Thank you.
Any more questions?
Sir, one question from chat box.
Yeah, please.
Challenges in multicolor printing.
Yeah.
From Venkatesh Rao.
Okay. Challenges in multicolor printing.
Yes, sir.
So only thing is the cost is high. You see polyjet, you can make multicolor printing. The cost will naturally have to make different resins and different things. Challenge is the cost of resins is high, and also the time taken of that product is higher, and also you can see the how much duration the product can there, and all those things. Main challenge is the cost and the process parameters, etc. I hope I answered.
Yes, sir.
Anyone, please?
Sir, one more question from chat box.
Yeah.
So can PLA composite material can be manufactured by AM process?
PLA is available. Composite metal printers are available. Any more questions? I hope I have not bored you. I met your expectations, what you expected.
Yes, sir. There is no more questions from chat box. And thank you
And
very
share the
much.
feedback to
The
me,
session
sir,
is
later.
very, yes, sir. The session is very informative session, sir. So I got the feedback from the chat box also.
Thank you. Thank you.
Yes, sir. Thank you so much, sir.
Thank you, sir. I'm leaving, sir.
Yes, sir. You can leave, sir. Thank you so much. Yes, dear